All right, scientists, in this video I want to show you how to take an energy equation and use it to create a formula that, if put into sheets, will use the data you enter to calculate the energy of your rocket at a particular point in its flight. And we are going to start with the first table here, rocket at launch, where it has its maximum velocity. I'm going to enter some data. Don't enter this data. Enter the data you collected from your video. This is the data I collected from my video. Okay, so the video I analyzed featured a rocket with a mass of 14.5 grams. Now, when you enter that data, that mass, the spreadsheet has already been programmed. Your template has already been programmed to take that mass in grams and convert it to a mass in kilograms. Okay, so when you do the calculations, or when you have the spreadsheet do the calculations, you're going to have it use this mass here, right here in cell C5. All right, now at this point, the maximum velocity of the rocket after it was launched was, for this rocket, I think about 33.1 meters per second, and at that point it was 1.01 meters above the ground. So this compressed aero rocket was well designed. It actually continued to accelerate for a few hundredths of a second after it was launched, because it was able to contain that compressed air. And as that compressed air exited the rocket, it pushed on the rocket as the rocket pushed it out. Third law says, boom, rocket continues to accelerate. Okay, so now you have the data in. Now you got to tell the spreadsheet what to do with that data. And we're going to start here in cell H5. We want cell H5 to be equal to the kinetic energy of our rocket. Okay, so that means cell H5 has to be equal to 1/2 the mass of the rocket multiplied by the velocity of the rocket squared. So our formula is going to be based on the second half of this equation in the right half of the equation in cell K4. Okay, now all sheets formulas start with an equal sign. That's a signal to the spreadsheet that you're going to tell it what to do. And the first part of that equation is actually just a number, 1/2. So we're going to type that in, 0.5. Now, remember, terms in an equation that are right next to each other, that don't have a plus or a minus or a divide symbol, it's telling you to multiply. So what you're doing here is you need to tell the spreadsheet to multiply 1/2 by the mass. And in a spreadsheet, the asterisk or shift 8 is used to indicate multiplication. Now, we want this rocket energy calculator to be able to calculate the energy of any rocket, of any data you enter. Okay? So we're not going to use the number for the mass. We're going to use the cell address. We're going to tell the spreadsheet where to go to find the number that represents the mass of the rocket. And that's right here in cell C5. So if you click right on cell C5, it automatically inserts that cell address into your formula. Boom. And then we're going to multiply again. Shift 8 again. And now we need the velocity. Okay? The velocity is right next to the mass in cell D5. Click again, and that puts that cell address into your formula. Now, when you square a number, you're just multiplying it by itself. So we could just put times again and D5 again. But spreadsheets recognize this symbol, called a caret, as essentially saying raised to the power of. So if you put that in and then put a number after it, it's going to raise it to that number, whatever that number is. A 2 raised to the power of 2 means squared. So put caret 2 tells you, or tells the spreadsheet, to square the number in D5. So now our formula is complete. We have instructed the spreadsheet to take 1/2, multiply it by whatever number's in cell C5, and multiply that by whatever the square of the number in D5 is. And that is going to give us our kinetic energy, because kinetic energy is equal to 1/2 the mass multiplied by the velocity squared. When I hit enter, it gives you a number. Now, what might happen to you guys is you might get a number that looks like this. A whole bunch of decimal places. Okay? You don't want that. So you can click on that cell and go up here to the 0 with the left arrow. That's a decrease decimal place tool. You can click on that until you get 2 decimal places. Okay? That's what we're looking for here. All right. Now for potential energy, you'll do the same thing, but your formula will be based on this equation, right? Potential energy is equal to mgh, or the mass times acceleration due to gravity, times the height. So you're just going to tell the spreadsheet to multiply the numbers in cell C5, E5, and F5. And then the final formula you need to write is going to calculate total energy, and it's based upon this equation right here. Total energy is just potential plus kinetic. So you're going to tell the spreadsheet to add the number in G5 to the number in H5. Okay, the basic structure of the formulas in the tables after this will be the same, except the cell addresses will be different. The mass will be in C9 instead of C5, for example. The velocity will be in D9 instead of D5. All right, scientists, hope this helps.